Okay, so this is Algebra Lesson 1.6 on pages 36 through 41 in your book. So if you go to a restaurant, Chinese restaurant, the question becomes, how much does it cost? And one of the ways that they figure out how much to charge you is by how many plates were delivered or how many plates you used up. So the question becomes, how much food did you order? So when you're writing mathematical expressions or equations or inequalities, it's called modeling, because you're modeling after something. So you could have a verbal model that gets turned into an algebraic model. The first thing you would do is you would write a verbal model. You assign labels to all the components, and then you can write an algebraic model. So let's say you and your friends are eating at a Chinese restaurant, and you order several plates that cost $2 each. And you get some wontons, some egg rolls, some dumplings, and your bill comes to $25.20, which also includes $1.20 of tax. So what I'm going to have you do with me is use modeling to find out how many plates you ordered. Okay, so we have our sections here. We have verbal there. We have our labels. And we have our algebraic model down here, and we'll put the answer down here. So our first section is cost per plate times number of plates, and over here we'll have the amount of the bill minus the tax. So the cost per plate is $2, and the number of plates are going to, here, let me fix this. This is kind of confusing. Let me erase that. We have the cost per plate is $2. It'll go on here. $2. The number of plates we don't know. We're going to use P for that. The amount of the bill is $2.50 and $25.20 minus $1.20 in tax. And our algebraic model, we would have our equation would be 2p equals 25.20 minus $1.20, and then we can reduce that down. 2p equals 24. P equals 12. So the cost, the number of plates we have is going to be 12 right here. And so they ordered 12 plates of food. So the way you problem solve these questions is you ask yourself what you need to know to solve the problem, and so that's your verbal models. So you write it out verbally or using words. Then you assigned labels to each part of your verbal model. Then you put all of this into an algebraic model, and you solve it, and then you check your answer. So it's very simple. Next example is about a football field. The little guy can run all over. Maybe he's a Dallas Cowboys. Okay. Oh, I don't know. Sometimes this thing is on and other times it's not. Okay, so let's say that you have a football field. It is 53 yards wide, 120 yards long, and then you have a soccer field that has the same area as this, but is 60 yards wide. Okay, so our verbal model is where we use words, and we have the soccer field width times the soccer field length equals football field width times football field length. And so the width of the soccer field is 60. The length of the soccer field is X. The length of the football field is 53, and the length is 120. And so now we can do our algebraic model, which would be 60x equals 6,360 because we multiplied these. So now all we have to do is to solve for 60x, which equals 6,360, and when we do that, we get 106. And you could have solved that with mental math by knowing that 60 times 106 equals 6,360. And so then the next thing we answer, and we check everything, and we would say the soccer field is 106 yards long. And our little soccer guy has to run 160 yards down the field. Our next example is about a jet. I don't think he went backwards. So for our next example, we have a jet pilot who is flying from Los Angeles to Chicago. He's traveling at 500 miles per hour. When the plane is 600 miles from Chicago, an air traffic controller tells the pilot it will be 2 hours before that plane can get clearance to land. Okay? So your question is, what speed would the jet have to fly to arrive in Chicago in 2 hours? So we've been given, we know 500 miles per hour, and we know 600 miles away, and 200 hours until 2 hours until he can land. So what we need to know, this is our verbal model, the speed of the jet times time equals the distance, and that is the RT equals D that you should have memorized by now. And to put it in out. I don't know if it's what this is getting. Let's see. So our answer is going to be to arrive in 2 hours. The pilot would have to slow down the jet to fly 300 miles per hour. Okay? Okay, so let's practice writing an algebraic model. For this example, you're going to run in a marathon. You're going to run, for the first 20 miles, you're going to run 8 miles per hour. Then in the last 6.2 miles, you're going to increase your 8 miles per hour speed by 2 miles per hour. So the question becomes, how long will it take you to run the last 6.2 miles of the marathon? And you can go through, you can write it out verbally, you can label everything, and then you can put together your algebra model. So let's see what we got. we would end up with, and so to solve this, we had 8 miles per hour the first 20 miles, and an additional 2 miles per hour in the last 6.2 miles, so that equals 10 miles per hour, so that's the rate. So we have our rate times t, and we already have the d right here, so what we have to solve for is the t, and what you end up with is 0.62 hours, so it'll take a little over 1 hour to run that last little bit. So you will do page 39, you'll do questions 1 through 10 today. Tomorrow you'll do numbers 11 through 26 and 30 through 33. And you will need to do a skills review on page 763, and then do questions 34 through 45. Okay.